All right, so let's work through some more examples using this property. Here's 4.3.5. And we want to think about taking the Laplace transform of some function f for f equal to 20t for 0 less than or equal to t less than 5, and 0 for t greater than or equal to 5. And so the first thing we want to do is represent f using using the step function, since that's something we know how to take the Laplace transform of. And so there's a couple different ways you can kind of think about starting this problem. For me, it helps to start with what my step is going to be. So I know this is going to use u of t minus 5 because my break happens at t equal to 5. But this one's a little different from the other examples we did. It starts at 20t and then ends at 0. So what I'm thinking is that I want f to be 20t when there is no u of t minus 5. When t is less than 5, I want to have that 20t. But then once u of t minus 5 happens, once we pass 5, this thing becomes 1. I want the 20t to go away. So I'd say, okay, I guess I subtract 20t times u of t minus 5. When I pass 5. And so what's going to happen is if we plug in like t equals 1, then I would get, 20 times 1. But this term is 0, so it would just stay at the 20t. But if I plug in like t equals 10, then I would get 200 there. But then u of t minus 5 is 1, so this would be 200, and then I would get 0. So this works for my function f. And now I'm thinking about how I would be taking the Laplace transform of this f. And I remember that what I need is for anything that has the u of t minus 5 to also look like a t minus 5. So even though it looks like 20t right now, I need it to look like a t minus 5 instead. That gives me 20t minus 20 times 5 is 100, so I better just add an extra 100 right there. Then that 20t minus 100 plus 100 is still 20t, but now it looks like a t minus 5, which is what I need to use my Laplace transform property. Okay, so now L of f is just L of 20t minus 20 times t minus 5 plus 100 u of t minus 5. So that's going to be L of 20t minus 20 times t minus 5 u of t minus 5 minus 100 u of t minus 5. All I've done is distribute my u of t minus 5 right there. So that's going to give me 20 L of t minus 20 L of t minus 5 u of t minus 5 minus 100 L of u of t minus 5. And then I have to remember that I'm using, where did I write it down last? This property right here. L of f of t minus a, u of t minus a is e to the minus as f of s. So f of t minus a, u of t minus a is e to the as. Why isn't this working right now? it goes, f of s. Okay. Oops, sorry, e to the minus as. Okay, so let's see. My 20 L of t, I don't have to worry about this yet. L of t is just going to give me 1 factorial over s squared. My L of t minus 5, u of t minus 5, now I have to use that property. So my f is t. So f of t minus 5 gives me that t minus 5. And my, oh, I guess I should move this down because I'm going to be writing a lot. And then my a is 5 because I see it inside of my u of t minus 5. So that means that I'm going to have e to the minus 5t capital F of s, where f is t. So that's, again, my f is just going to be 1 over s squared. And then to compute L of u of t minus 5, we could think about f being 1. Then capital F is 1 over s, but our a is still 5, so that's minus 100 e to the minus 5t 1 over s. I also just gave that to you on the table of references at the start, so it's fine if you just want to write that down directly from your reference table as well. But all that right there is our answer. I'm not going to do the whole box, I guess. I don't want to write over stuff. And I'm going to go ahead and stop there because I think another example would take us longer than 10 minutes.